Okay, so today we're going to be solving integrals with u substitution. For the first step, you write the integral down times dx. And for the second step, you would put u and make it equal to what you want to set as u. And then since u and x are interchangeable, you can use the u equation to solve for x. But that's only for certain questions where you need the x. And then you would take the derivative of u, place it here to have du equals the derivative of u times dx. And then you would solve for dx by dividing the derivative under du. So dx would equal du divided by the derivative. And then for step 3, you would substitute in u and du. For step 4, you can pick one or however many you need out of these 3 to help you simplify, rearrange, or pull out a constant so that you can get u and du by themselves. And for step 5, you integrate. For step 6, you simplify once you're done integrating to make step 7 easier on you. Plug in u, then add c if there are no bounds. No bounds is just the integral by itself. No numbers above and no numbers below. For the first step, we are going to write the integral of x over x squared plus 5 times dx. For step 2, I'm going to pick the bottom of the fraction to set as u. U equals x squared plus 5. Then x and dx is needed here because you're going to be left with x over u. However, I have an easier step where you can take care of x and dx in the same step. X times dx equals. So you would take the derivative of u, du equals 2x times dx. So you see the x and the dx are here. We would just divide the 2 over, and we'd be left with x times dx equals du over 2. du over 2. For step 3, you would substitute them in. So you'd be left with, just to show you how it cancels. So x times dx times 1 over x squared plus 5. Then you would substitute, and it would be du divided by 2 times 1 over u. Then for step 4, you would either simplify, rearrange, or pull out a constant. I'm going to pull out a constant for step 2 right here to get du by itself. And you're left with du times u to the negative 1. 1 over u is the same as u to the negative 1. Then, for step 5, you would integrate. And du would cancel, and u to the negative 1, the integral of that is ln absolute value u. So that would be 1/2 times ln absolute value u du. For step 6, you would simplify 1/2 times ln u plus c. Because there are no bounds in this equation, you would just be done by putting plus c. So now the very last step is to plug u back in. So 1/2 times ln, and you'd plug in back u. So x squared plus 5 absolute plus c would be your final answer. And that's how you integrate using u substitution, with a shortcut of x times dx to get du divided by 2 in order to take out the x and the dx in the same step and replace it by du divided by 2. It's just a simpler way of doing it.